In our final lesson in this course, we're going to discuss how you would find the expected value of an event. So the idea is that the expected value is really the same thing as finding the average or the mean of what you would anticipate would happen. So here's your formula for expected value of a random variable. And you might see it expressed this way. The expected value of some event X is the sum of all of the outcomes you could have, the X's, times the probability of each event. And as you look at these tables that we're being provided, if they're asking us for the expected value, they're showing us the different outcomes that can happen. Those are going to be the X values. And the probability of each outcome is the p-value. Now, one thing we should recognize is if this is a probability distribution, it should include every possible event that could happen. And the way we can make sure we've covered that is these probability values should all add together to equal 1. Now, I will tell you they're not going to be sneaky and provide us with something that is not the case, but you should be aware if we've entered every possible outcome, then all the probabilities should sum up to be 1. So if we were doing this problem manually, just using our formula, we would want to take each X value, so our expected value of X would be equal to, our first X value is -2, we're going to multiply that times 0.5. Then we add to it the next X times the probability. Well, 0 times anything is going to be 0. That one will be easy to calculate. Plus, the next outcome is 2. The probability of that is 0.1. Plus, the last event that can happen is you can get 4, and the probability of that is 0.1. So if you go to your calculator and you multiply a -2 times 0.5, add to it 0, add to that 2 times 0.1, and add to that 4 times 0.1, I'm coming up with a -0.4 for the expected value. Now, as long as you don't have very many items in your table, calculating that manually is not a problem. I do want to explain, though, the way you can calculate this using the TI either 83 or 84 graphing calculator. There is a feature that lets you put these tables directly into the calculator. So if you go to the button that says Stat and you hit Enter, which allows you to edit, what you will see would be columns that are titled L1, L2, and so forth. And what you would want to do is put all of the X values in L1, so you could enter in -2, 0, 2, 4 in your L1. If you'll use the arrow button to the right to get into the L2 column, then you can put those probabilities in. We would have 0.5, 0.3, 0.1, and another 0.1. If we've done this correctly, we should have exactly the same number of items in L1 as we do in L2, and it's always a good idea to double check to be sure that your entries are put in correctly. Now, from there, if you'll go back into Stat, now that you've entered those items, and I'm sorry, you want to go into Second Stat and arrow over to Math. That will allow you to choose the feature that says sum, which is probably going to be number 5 on your calculator. And now you need to tell your calculator what you want it to sum up. And what we want it to do is to multiply L1 times L2. And so when you hit the sum button, it opens up a parentheses. And to tell it L1, you need to hit second 1 times second 2. And now when you hit enter, it will give you your answer, which happens to be the same thing we got when we did it manually, a negative 0.4. In other words, that would be the average of all of these events. That's what you would expect to happen on average, is you would get a negative 0.4. Okay, now here's another table. This one has a few more items in it. Again, you can do it manually, or you can use the stat feature. I'm going to give you an opportunity to decide which way you want to do this, and you can either enter it in following the instructions that I gave above on how to put it in your calculator in L1 and in L2, or you can just simply multiply these out manually and then add up all of those sums. Okay, so I have entered mine into the calculator. So I've gone into stat and edit. Now I'm ready to go into second stat, and I'm going over to math to choose sum, and I'm just telling the calculator multiply together L1 times L2. And I have an expected value of x that is a negative 0.55. On average, I should expect negative 0.55 to be the outcome. Now, this doesn't necessarily make a lot of sense in this particular format of a question, because obviously negative 0.55 isn't even one of the outcomes you can have in the table, but this is letting you know on average what to expect. As we go to the next page, we're going to see more of a practical example of when this might be helpful to know. You can do number 3, just to see in a real world setting. This is the probability distribution of the number of packages in thousands that are handled by a shipping company. Find the expected number of packages handled on any day. So this is going to have taken data from a number of days that would have happened to where the likelihood or the probability that they handle 4,000 packages would be 0.2 or 20% of the time. Look at this, all the way up to 16,000 packages would be a 40% likelihood. Well, we're going to find the expected number of packages that would be handled on any day. So again, I'll do this one manually just to remind you how you get this done if you don't want to use that graphing calculator feature. And that would mean we would have to take 4 times 0.2 plus 8 times 0.1 plus 12 times 0.1 plus 16 times 0.4 plus 20 times 0.2. So we're going to have to do all of that calculating. So I'm going to give you a second to work through that, and we will see what we would expect the average number of packages to be on any given day. So as you're computing that, I'll just mention our next example is going to be one that if you happen to like buying lottery tickets or gambling in some way, you might want to pay attention to, because this will help you recognize whether you would be wise to play some of those games. And what I have come up with, as I have done the calculations on this problem, is 13.2. That would mean you would expect 13,200 packages to be handled on any given day. That would be the average you would expect. Now, this last example says a 5-card hand is dealt from a standard 50. Oh, this is not the one I wanted. Dadgummit.